So it's Unit 2, Lesson 7, so we're getting into the first step of factoring now. So the hard part for you is we're doing the other direction now. Okay, and so in this unit we introduce a process of factoring. This includes factoring by removing a common factor. That's what we're going to do today. Monomial, binomial, and grouping. Factoring a trinomial with inspection and decomposition. And factoring difference of squares. Those are the big chunks we're going to learn. The good news is, if you get really good at this, you're guaranteed going to ace your Unit 2 test in Math 20 because we just took that test, and it was all of those except for 2 others, okay, of factoring. So it's not too bad at all. And then these techniques are illustrated concretely, pictorially, and symbolically. We express a polynomial as a product of factors. This is the key word I want to point out, product of its factors. So what we're doing when we factor, we're making it a product of 2 things. I know that sounds weird, but we're making a product of 2 things. So like right here, that's a product of 2 things. So what we're going to be doing is, what we did last section is we said distribute, right? Well, what's going to happen this section is we're going the other way. Okay, so we're going, okay, distribute, distribute. So we're 2x squared plus 10x. We're given this, and we're going back to that for factoring. So we're given 2x squared plus 10x, and we're going backwards to making it a product of its factors. Exactly. We're going from here, we'll be given this, and we're going back to this. So the reverse order. Okay? Now, some of these things, I'm going to do them, and you're going to be confused, just because this page right here frustrated last class. This page is an overview of the whole unit. Okay? We're not going to do all these in one day, so be patient. So we foiled this one normally. We'd get x squared plus 3x plus 1x plus 3 would be x squared plus 4x plus 3. So we'll give it given this, and we have to give back to that. Okay, factor. It's a number thing. It's a number pattern. If you're good with multiplication and you're good with your mental math, you'll do it quicker. If not, it'll take a little bit longer, but not a huge deal. Okay, and then 2x times x is 2x squared. 2x times 4 is 8x. 3 times x is 3x. 3 times 4 is 12. So this one works out to be 11x plus 12. Just reviewing what we've already done. And then the binomial by binomial, we remember from last time the pattern, if it's an x minus 5 and x plus 5, we don't have a what? Middle. So the middle's gone. That's why it says a binomial binomial to form another binomial. This will end up being x squared minus 25, because we get the minus 5x and the positive 5x. Okay, so we're going to move it down in a second. I'm going to identify what each of these are one of the things they introduced above, and I'm going to tell you what they are in a second. I would like you to write them so that you can kind of see what they're talking about. Whoops. Okay, we got one more. Okay. So in these examples, we expand the product of polynomials from the sum or difference of monomials. In this unit, we are concerned with the opposite process. So we're given this, and we need to go back to what we had up there. So this one, I want you to label here on the side. This one is the GCF example, greatest common factor example. That's what we're going to learn today. Okay? And what's that?
Are we doing the whole thing of the lesson?
Today, yeah. We might, if we have time, we might not get to that cone one, but yeah. So what happens here is, and I'll get to this, so you're not going to understand what I'm saying right now, so be patient. But these both have a 2 in common and an x in common. That's their greatest common factor. And so we pull a 2x out. And once you identify your greatest common factor, you divide it out. So what's 2 divided by 2? 1. It's gone. What's x2 when I take an x out? X. So I'm left with an x here. What's 10 divided by 2? 5. What's x divided by x? It's gone. So we just did that. That's the GCF we're going to learn today. Okay? We divided it out. Now it's a product of factors. So you factored it. Does everybody understand that wording there? It's a product of factors because they're now set up in multiplication form. Exactly. We're reversing the process. Okay? Now this one's going to drive you nuts. Okay? But how you're going to do this one, I'm just introducing it. So right now you're not going to understand it. Okay? So accept this. This is how you do it. This is called inspection. is what this one's called. We'll have a lesson on it. But what you do is you look at the last constant and you say, okay, what factors of 3 are there? 3 and 1. That's your only option. What's 3 plus 1?
4.
What's in the middle?
2.
4. 4. So what we figured, it has to be this for its factors, because x times x is x squared, 3 times 1 is 3, 3 plus 1 is 4. Mind blown. It's okay. It's okay. It's all right. This one's going to be even worse. Okay? This one's going to be even worse. So I'll do, this one's called decomposition. Decomp. I'll show you this one quickly, which is probably going to make it worse, but I'm going to show you quickly more so that you forget quicker. Okay? This one, there's a number in front, so it's not as simple. You can't just do the factor of this number. You have to multiply the front and the back to get 24. 2 times 12. And then what you have to do is, okay, this is completely generalized. This is completely the beginning, so please don't panic. 24, I need factors of 24 that add up to 11. So what factors of 24 are there that add up to 11? Well, I mean, 24 and 1 is 25, but what other factors of 24 are there? 8 and 3. 8 and 3, 8 times 3 is 24, 8 plus 3 is 11. That's what we're looking for. And so what we do is, we have to factor by grouping now. So what we do is, I'll show you. So what I've done is, we identify what we have to break it up into. We broke this 11 up into 8 and 3, because now we're going to group them in groups of 2. The only reason I'm showing you this part is because now we're going to do this step, which we're doing today. What do those have in common? 2x squared and an 8x. A 2 and an x. That comes out. X, what's 8 divided by 2? It's 4. The x came out. What's a 3x and a 12 have in common? 3. Okay, so the 3 comes out, so that becomes x plus 4. They match. That means you did it right. That's one of your factors. Again, I'm just introducing this, so please be patient. So x plus 4 is one of your factors. The things on the outside, 2x plus 3. That's the other one, and you're done. Two x plus 3 times x plus 4. Yeah, get ready. That's a big time right there, Ty. Okay, factoring differences of squares is a bit easier because they're a pattern. Because is x squared a perfect square? Yes. Is 25 a perfect square? Yes. So as soon as you notice that, you'd say, oh, that means it's the one without the middle. And so you'd write x plus 5, x minus 5, because that's the square root of 25. Yeah, like difference of squares, so it's okay? Okay. This one's going to be the death of you.
Yeah. Actually, that one isn't bad. I think you just need to practice with it.
That's correct stuff.
I just can't remember how to do it if you told me to do it right now.
That's all right. Okay, so but now for now, that was a general overview of the whole unit. So obviously I'm not teaching you a whole unit today. We're focusing on GCF, greatest common factor today is all. And so we're going to go through here and just kind of remember how we do greatest common factor. They're going to give you a couple baby steps, and at the end we're going to do the actual process by itself. So in the unit on the number, we met the concept of greatest common factor. We already done this in our very first half of our unit 1, where we broke them down into their prime factors. And you circle what they had in common. So for example, this has 3 2's. And so we take 3 2's from here. This has 1 3. 1 3, so we take 1 3 from there. So it was 3 2's and a 3. 2 times 2 is 4, times 2 is 8, times 3, so it's 24 is the GCF for 48 and 72. Correct. Okay, So now, when we introduce the same concept with variables, we just write them out, and then we say what they have in common. You're not going to do this all the time because you're going to get used to the pattern. This is just introducing the basics, okay, the nuts and bolts. So 6 breaks down to 2 times 3. I have 3 A's. 9 breaks down to 3 times 3. I have 2 A's and a B. So we go through. What do they have in common? They have 1 3, 2 A's, and that's it. So 3A and A, so the GCF is 3A squared. That's your greatest common factor of those two terms. Any questions on that? Okay. So we're going to do it out one time here. Like I said, we're taking baby steps. Did I go too fast? Oh, okay. Okay, so I'm going to break down the 8. So 8 is 2 times 2 times 2. I have an x, I have an x, I have a y, I have a y. Compared to 20, 5 times 2 times 2 times x, y, y, and y. So what they have in common, they have 2 2's. I know, it always likes me to say that, doesn't it? 2 2's and 1x, 2 y's. Those are the things we have in common. So 2 times 2 times x times y is my GCF. 4xy squared is my GCF. Yes.
Do you always have to have like the what's it called? Like lowest number you can get when you're doing like the 8 and then the 20?
Yeah.
Like, because like 8 could be 4 times 2, right? Oh yeah, prime fact. Oh
Yeah, yeah. Right. And this, you're not going to do it this way every time, Teague. We're just kind of doing the real basic. Like down here, we're going to end up just seeing like, down here if I said, Tegan, what does 12 and 15 have in common? You'd probably say a 3. That's what it is. We're going to pull a 3 out. Okay? So we're not going to have to prime factorization every time.
Okay.
It's more showing you why we're pulling it out. It's because what they have in common. So it's showing you how to do it. But once you guys, because you guys have good number sense, like I said, everyone here knows that 12 and 15 have 3 in common. So that's what we're going to pull out. Then if I have one A and I have 2 A's, what's the smallest A I can take out? A 1. I can only take one of them out, right? So that's what we're going to be doing next, okay? So
Junior clock change.
let's go through these ones. So all this one says is in each case, state the greatest common factor of the following. So we're not pulling them out yet. That's, like I said, we're taking baby steps. So you're just talking about your greatest common factors. So like we just talked about, we all agreed that's a 3 and an A, and then what's the B I can take out? A 1B. So 3AB is your GCF there. That's it. And so what will happen is, and I'm getting ahead of myself here, but we're going to have a brackets, and then we're going to divide this out and see what's left. Okay, that's going to be the next step. All right, so Thomas, what do you see? Tell me for B. What do you see for your greatest common factors on B? 6, perfect. Good. Good. Okay, only take a negative if they both have a negative. Only take a negative if they both have a negative. If only one has a negative, you don't need to take it out. Okay, if you do, it's not wrong though. Just letting you know, that's what I generally do. Okay, Chloe, you want to try C?
Sure. Can only take out a 1.
Right, so no number, so that doesn't count. So no number can come out here, good.
And then 1A
Good,
and 2C.
good. So they had stuff in here you couldn't take out. So we couldn't take a number out because 2 and 1, can't do anything there. And then they had a B that we couldn't mess with. So AC squared is all we could do. Okay, good. Hunter, what number does these have in common? They'll all be a 10. And since they're all negative, we'll call it negative 10, okay? All right, Ty, how many A's can I take out?
A squared.
Okay, good. And then Jake, how many B's can I take out? 1, good. Negative 10A squared B. Good. All right, moving forward. All right. Oh, where'd it go? Oh. Page thing is weird today. Look at that. All right. Where am I at? All right. Okay, so now we're working on the actual piece of pulling it out. Okay. So what it's saying right here is factoring a process which sum or difference terms express as a product. So we're trying to make it look like a product now. We identify the thing we're taking out. Now what's left is what we're focusing on. Okay? So for example, in this one that was above, we took out a 4xy squared. When you do that, 2x plus 5y is what's left. Okay? This is what the factored form looks like. Okay? The product of two terms. So if we come down here, like I said, they're going to give you guys a couple baby steps here. So the first thing we're going to do is we're going to say, okay, this is what we had. That's what's left inside. So what's the GCF? So what's the GCF of 21x and 14y?
7.
Just a 7. I can't do an x. I can't do a y. It's just a 7. Okay, so what's the GCF for b? 5, not x squared. Good, 5x squared. Way you can check by doing this. It's pretty simple. What's 5x squared times x squared? Check, that's right. What's 5x squared times 3x? Check, 15x cubed. 5x squared times 1 is the 5x squared. So you can check with like, oh, okay, I do have it right. I did pull out the right thing. Okay, now a step further. They're giving us what we pulled out, and we want to figure out what's left inside. So what you do here is, okay, 5a squared, I took a 5a out, a. Oh, nothing else goes there but the a. If I took an a out, or 5a out, 25a's here, what has to be there? 5. Because 5a times 5 is 25a. So essentially, I did 25 divided by 5. So then on B, they have a 2 in common. 9p is all I can do. The 8q is already done for me. Good. All right, Steph, what do you think's left on C?
2n.
So 2n. Okay, I like that.
And 3m.
Plus 3m. Yep. So if you check it, negative 2 times 2 is negative 4. M times n is mn. Negative 2 times 3 is negative 6. M times m is m squared. Sorry. Getting tired. Okay, and the last one here. 9x that we're pulling out. So that means 18 divided by 9 is 2. X. Yep, keep the y squared. And then we have minus 5. That pen's not working that good on this side here. Minus 5 y. And then just plus 1, right? Good. You guys get the hang of it? Okay, and then for the last piece here, we'll stop after this one. It's been a long day with the quiz. Okay, these ones we're putting it all together now. Okay, so I'm going to give you guys a second. I'd like you guys to go ahead and try those 5, and then we'll go through them, just kind of see how you're feeling about it. So just try those 5. I'll give you a couple seconds. Here. So we got 20x minus 6, so what do they have in common? Just a 2. Okay. B, 16x to the 4th plus 4x squared. 4x squared. 4x squared times 4x squared plus 1. Okay, C, a 2, an A, and a B2. So 5a squared plus 4b plus b squared. Okay. Okay, and then this one here, they all have a p in common and a 3. 4p squared minus 2p plus 5 okay, and then these have a 5 in common. An x, y2, z2. So that's 5 z minus 4 x y2 and plus 6 x3, y2's out, and z3. Okay. Everybody good? Okay, we'll stop there for today.